Hi, Algebra 2, Ms. Hendry here. This is section 2.4, Solving Systems of Equations Algebraically. Our previous lesson had us solving systems by graphing, but graphing systems does have a downfall. And like, what if the point isn't exactly on a whole number or integer? So maybe the graphing is not going to work. That's why we need some algebra magic. So we're going to be solving systems using substitution. And we've used substitution several times. And remember, substitution is where we make an equivalent substitution into a problem. Kind of like two $10 bills equal a 20. So that's when we can use substitution. Now, when looking at number 1, we're given that x plus y equals 3. But look at the second equation. In the second equation, we are given y in terms of x. So everywhere we see y, we can plug in 3x minus 1. And that's what we're going to do. And we are going to use substitution. So x plus y. Y is 3x minus 1 equals 3. So we have a new equation in only one variable, and this can easily be solved. X plus 3x is 4x, and minus 1 equals 3, plus 1 plus 1, 4x equals 4, 4x equals 4, x equals 1. We found the coordinate for x by using substitution. Remember, we're not done because the solution to our system is going to be a point in the form of x comma y. So we've got to take x equals 1 and we need to solve it for y. The easiest place to substitute it in is the y equals equation right there. So y equals 3 times x. Note my use of parentheses. 3 times x minus 1. Follow order of operations, 3 minus 1, and of course 3 minus 1 is 2. So we've got our x and we've got our y, therefore the solution to our system is 1, 2. These are just like the problems that we did back in the good old days of Algebra 1. Let's do the next one. xy minus 8x minus 3y equals negative 1. X plus 2y equals negative 12. Now in this one, we do not have an equation that has been solved for a variable. So we need to pick which one appears to be simpler. It appears to me that we can get that x by itself very quickly in just one move. We can take the 2y that is positive on the left, subtract it from both sides, and get x equals negative 12 minus 2y. So taking that 2y from the left to the right, the positive is going to become negative. And now we know x in terms of y. So we can go to that top equation and we can use substitution and plug in the x. So 8 times x, note my use of parentheses here because all of this is going to get multiplied by 8. So 8 times negative 12 minus 2y minus 3y equals negative 1. Use the distributive property right here. 8 times negative 12 is negative 96. 8 times negative 2 is negative 16y minus 3y equals negative 1. We are going to now locate our like terms, which are the y terms. So negative 96 minus 19y equals negative 1. From here, we're solving for y, so I'll be adding 96 to both sides. Negative 19y equals 95. And guess what, ladies and gentlemen? 19 is divisible, or 19 is a factor of 95. It is negative 5. Now, we solved for y, but we're not done because we want to know x. So let's take this value for y equals negative 5, and let's plug it in right there using the substitution property. So negative 12 minus 2 times y of course is negative 5. So that gives us, I'm going to squish it in right up here, Negative 12 plus 10. Negative 12 plus 10 is, of course, negative 2. So there is, not x, not y, but x. Our x value is negative 2. So our answer for number 2 is negative 2, negative 5. That is solving by substitution. Of course, 3 and 4, I'll get them set up for you and I'll let you finish those off. Number 3, we can easily solve for this y. We can do that by taking that negative 5x, shifting to the other side. So I'm transforming this top equation. It's going to be y equals negative 3 plus 5x. So there's your y, and you can substitute it in right there. Go ahead, finish that problem. Finish that problem and go to number 4. Number 4 is great because guess what? Y is already solved for. Y is 2x minus 11. So let's plug it in right there where we see the y. So we end up with negative 5x plus 2.5 times y equals negative 15. Once again, guys, note my use of parentheses. That reminds you to use the distributive property. So I will, I'll do the decimals for you because I know that those kind of freak people out sometimes. So negative 5x plus 2.5. Think of 2.5 like money. It's $2.50. 250 times 2 is 5. So 2.5 times 2 is 5x. 2.5 times 11. Let's think about that as 11 times 2 is 22. And then 0.5 of 11 is 5.5. So that is minus 27.5. Now we can't, oh no, can we solve for x? Oh no, people. Negative 5x, positive 5x, that cancels. And we end up with negative 27.5 equals negative 15. What in the world? True or false? It is false. Ooh, there you go. You got an extra problem out of me. Turn the page over to the back. Different method, elimination method. And lots of times this is everybody's favorite method because lots of times it's the shortest. Now, what needs to happen for the elimination method is first thing we got to look for is, are our equations in standard form? Remember, standard form is ax plus by equals c. And x is ax over ax plus or minus, the y's, the equal signs, the constants. Everything has to be lined up in order for elimination to work. Let's first start with number 5. And remember, back from the good old days of Algebra 1, in order for something to eliminate, we have to have opposite coefficients. Opposite coefficients. So first of all, opposites, an example of opposites, how about positive 9 and negative 9? Those are opposites, and when we add them, we get 0. Remember, coefficients are the numbers in front of the variables. So if we have, like this guy, 2x, 2 is the coefficient. So we need opposite coefficients in order for elimination to happen. So when we look at number 5, we've got 2x and 4x. We've got 9y and 9y. Those aren't opposite coefficients. Those are same coefficients. So what if we multiply this bottom equation by negative 1, and remember, whatever we do to one side of an equation, we have to do to the other. This will, when we use the distributive property, give us some opposite coefficients. So negative 1 times 4x, negative 4x, negative 1 times 9y, negative 9y, equals negative 1 times 23, negative 23. So we just transformed that bottom equation. So now let's bring down that top equation, put it right underneath it. 2x plus 9y equals 25. Now we have the opposite coefficients right here on the 9s. Now we can do elimination. Remember, when we do elimination, we're just going to add right down the columns. Negative 4x plus 2y, or excuse me, negative 4x plus 2x is negative 2x. A negative 9y and a positive 9y are opposite coefficients. They will cancel. Equals negative 23 plus 25 is 2. So we end up with negative 2x equals 2. Divide by negative 2, and we get x equals negative 1. Remember, we're not done yet, so we need to take that negative 1 for x and substitute it back in one of the equations. I'm just going to go with the first one because we haven't done anything to it. So 2 times x is negative 1, plus 9y equals 25. Negative 2 plus 9y equals 25, plus 2, 9y equals 27, y equals 3. There's my x, there's my y, and now I know that for number 5, the answer in x, comma, y form is negative 1, 3. Now, let's take a look at number 6, and that'll be my last example. So 2x plus 5y equals 1. 3x minus 4y equals negative 10. We need opposite coefficients. So we just need to make a choice here. Will we go after the x's or will we go after the y's? It's really your choice. I will choose the x's. So if we want opposite coefficients for the x's, then this first equation I will multiply by 3, which will transform it to be 6x plus 15y equals 3. 1 times 3 is 3. Now, for my second equation, remember I want opposite coefficients. I'm going to multiply by negative 2. I'm going to multiply by negative 2, and look what will happen. Negative 2 times 3x is negative 6x. Now I have opposite coefficients for my x terms. Next, remember we're distributing here. Negative 2 times negative 4 plus 8y, and a negative 2 times a negative 10 equals 20. So now my x's are lined up, my y's are lined up, my equal signs are lined up, my constants are lined up. But now, what do I have? I have opposite coefficients on the x's. A positive 6 and a negative 6 cancel. 15y plus 8y is 23y. 3 plus 20 is 23. It is a miracle that y equals 1. I know why. We are going to take that y value and use substitution and plug it back in. You can choose the top or the bottom. It does not matter. I'll go for the bottom this time. 3x minus 4 times y. Y is 1 equals negative 10. 3x minus 4 equals negative 10 plus 4 plus 4. 3x equals negative 6, x equals negative 2. There's my x, there's my y. My answer for number 6, remember, it comes in the form of x comma y, is negative 2, 1. There you go. There's some beautiful notes and examples for you to complete the homework for this section, which can be found in your textbook on page 103. And I would like for you to complete 1 through 6 all and 9 through 14 all on notebook paper. Please use the lines and show your work neatly. Thank you.